Hi everyone, I spent a few hours during the weekend building an 18650 battery pack to power my leather workshop. I want to show you how I did it, step by step. Let's connect my heavy duty sewing machine. You see that it's working? I really want it to be compact, so this is going to be the home. All of when it's done, we will stack it into this electrical box, put charge controller at the top. It's going to be a 3S14P, so I put my 7, so I have 1, 2, 3, 4, 5, 6, 7, right? But I've doubled the cell, so it's going to be 14 parallel and then 3 series. So from 3.7 volts of each cell, we want to make it 12 volts, which means you see that all of these are positives. All of these that you find here are positive, and all of these are negatives. Then all of these are positives, which means we're going to connect this positive to this negative. That way, if we take a reading from here and there, we will get 12 volts. See, in series. But then to build up our capacity, we have now connected all of these in parallel. So which means that the total capacity of this entire battery pack is going to be the capacity of each cell multiplied by 14, because we have 14 in parallel. These ones that I'm using are generic cells that on the average they come to about 1200 1200 mAh per cell, which means that that's going to be about 16, the whole battery bank will be about 16 AH when we are done. Just fold 1, 2, 3, 4. This is how I do mine. I just got this out here and so let's start the work. So what I do is I turn this on. So hold it at the 2 extremes and then do this other. So what you need to understand again is, so all of these are now in parallel. So each of these are one cell. Of course, I haven't connected the underside to make them truly one cell. So you can view this as one cell that we're now going to connect in series. So just like the example we started out with, so this is one battery cell. But let me go ahead and turn this over and do the same thing. So I want to be 4, 6, 6. Like this. So in this Remember I said this is one cell, this is one cell, this is one cell. Not quite, at least not at the moment, because you see this is separate from this. So we need to bridge them. We can bridge them on all the junctions, but it suffices to bridge them in 3 places. So we need this, 2, 3, 4. So we've got our 3 cells connected here, connected here. Now let's build the series connection. So this is positive, negative, positive. So we'll connect positive, this whole cell, to this. So the reason why I spaced this like this is because I'm now going to add strips across like this, strips across like this. That way the whole thing is connected. So I need 2, 4. Yeah. Then I'll flip over and do the reverse. So let's do that. Well, let's have strips first. So we need this lock, right? So at the end of the day, this is what we have. So you see we have positive, negative, positive, right? This positive here is connected to this negative, and then when you flip over this way, that is connected to this. So we basically have 12 volts. Let's test out to find out if that is actually true. Volts. Typically, I'll just leave this way for all of the cells to balance. But of course, you can't use this like this. You have to add a BMS, a battery management system, so that it doesn't overcharge and it doesn't over discharge. So let's go about installing the BMS. But that's okay. That's okay. Now this is the BMS. So it's been left in this state for almost 2 hours, just so that all of the cells can balance. So this is the BMS. It's a 3S 40 amps BMS. I think that is ample power for this battery. Let's add the terminals. When I started out making solar 18650 battery packs, one of the most difficult things I faced was how to solder. I don't have an electricity or electrical background, so soldering was a serious issue for me. It's still a problem, but I think I'm getting the hang of it. I'm becoming a little bit my skills are improving. So not strong enough. So let's finalize. So this is my 16 amp hours battery. Tomorrow I will cut this board properly, cut it to size, put a charge controller here. These wires will go through the back and connect to the charge controller, and then we'll load out, put a voltage indicator somewhere here, such that the user can gauge his battery capacity and then also charge phones from here. So it's a charge controller will be put somewhere here, and then an inverter somewhere there. So that becomes a full solar system, mini solar system. What can this battery power? This battery will power your DC fan. This is a 200 watts. This is a 200 watts battery, meaning it's almost a 300 watts battery, meaning it can power your TV. In any case, just so that we test it out. See, that's a heavy duty sewing machine. That's an industrial heavy duty sewing machine. I'm going to attempt to power this machine with this battery. Let's see if it works. Okay, so you can see this is a they say 3,000 watts, but that 3,000 watts is just the surge power. This is a 300 watts Versace inverter. At the moment, I'm powering it using these deep cycle gel batteries, motorcycle batteries really. That's much of the electricity in my workshop is generated from these batteries, right? This one here is, this black one that you see here is 18 amps, and this is 9. Both of their gel batteries, and you can only discharge just about 50% of their capacity. If I switch on, you see, you can hear the fan of the inverter is on, so you can see that the inverter is powering on. But because we want to test this, battery that we just built, this battery, I'm going to, at the moment, disconnect these batteries from the inverter. So you can see the inverter is off. Inverter is off, right? So let's keep that away. Now let's take this battery and connect it to the inverter. Let's connect the negative terminal first. So I really need to see what's going on. So there, this is the battery that we just built. So connect the negative terminal to the inverter. So you can see the inverter is immediately back on. But let's switch off the inverter. Let's switch the switch on. So right now we're powering this inverter. We're powering this inverter with this battery. And let's connect my heavy duty sewing machine. So again, this is the sewing machine and this is the power cable. So you can see that's the power cable from the switch of the sewing machine. Get this out of the way. So let's connect the sewing machine to the inverter. So connecting the sewing machine to the inverter, switch on the inverter, and you can see the light of the sewing machine is on. So will it power the sewing machine? I believe so. Let's put some leather. By the way, if you guys don't know, leather work is something else that I do. So let's see if it will power on. And so you see that it's working. It's powering it. This will power your blender. This will power your fridge. Yeah, it will power a fridge. A DC fridge. It will power a DC fridge. The only drawback will be how long it will power it. I believe you have a solar panel. If your DC fridge is rated for 75 watts and you have a 200 watt solar panel connected to this battery, it will power the fridge throughout the day, and you'll have sufficient battery power to power a fan or two throughout the night. So this is a very capable battery, in my opinion. So like I mentioned, I'm going to add the charge controller to it and add all the other peripheries, and then send it out to my friend who requested it.